Okay, guys, so we are going to start Chapter 10. This is the first section of Chapter 10, and we've got simplifying radical expressions. So we've got a few key concepts here, so please get these copied into your notes and replay me when you're ready for the explanation. Okay, so first of all, we've got radical expression, and this is an expression that contains a square root. And remember, a square root looks like this funny little shape here. And the radicand is the expression under the square root sign. So everything underneath the square root is called the radicand. We've got the product property of square roots. So we've got the square root of a product a times b. And we can split this up into square root of a times the square root of b. And that all you want to do is you just split it up and keep a square root over both of those. The quotient property of square root is the square root of a over b, a fraction or a division. And we split that up into the square root of a over the square root of b. So again, we split it up as a one division problem and a square root sign per side. Okay, now this is a rule that may not make a whole lot of sense now, but once we start doing some examples, it'll make a little bit more sense. So what we need to know from this is if the resulting simplified exponent is odd. So we're going to be simplifying with exponents and variables. And if we pull out something that is odd, an odd number, you got to use absolute value signs to ensure non-negative results. Okay, so if I pull out an x, so our exponent is odd, which means it's 1, right? I've got to have absolute value bars against it. If I pull out an x cubed, okay, now my exponent is odd, I've got to have absolute value bars around it. And this will just ensure that I won't have non-negative results. Okay, and then finally we've got rationalizing the denominator, and this is a method used to eliminate radicals from a denominator. And I'll show you how to use that in some examples later on. But just know that we can't have radicals in our denominator because then our radical expression will not be simplified. Okay, here's our first example of how to square root a number. Square root of 90, and we're going to simplify that. So first of all, before we get started, I want to make a factor tree. So this is 9 times 10. 3 times 3, and 2 times 5. So we want to list these under the radical sign as 2 times 3 times 3 times 5. Okay, so all I did here was I just made my prime factorization, and I'm listing all my prime factors under the radical sign. Okay, now once I've done that, I want to find all of my pairs. Okay, pairs come in 2. So I've got 2 3s here. Okay, no other pairs, just one set of 3s. And what I want to do is I want to cross it out, bring it out. And whatever I'm left with underneath, I'm going to multiply together. So 2 times 5 is 10. So the square root of 90, simplified, is 3 square root 10. 3 on 10. Okay, now here's your turn. I'd like you to give this one a shot and replay me when you're ready for the answer. Listed, we have 3 times 3 times 3. One pair, cross it out, bring it out. And our answer is 3 square root 3. Okay, now that we've got a product, we want to write this as one combined square root. So we're actually going to take the radicands and multiply them together. So I'm going to have square root of 3 times square root of 15 as square root 45. Now from here is where you're going to do exactly what you were doing before. So we're going to have 9 times 5, 3 times 3, square root of 3 times 3 times 5. Find one pair, cross it out, bring it out. And I'm left with 3 square root 5. So the square root of 3 times the square root of 15, we've got the square root of 45, and we factor out 45, and we find that it's 3 square root 5. Okay, now here's 2 examples I want you to try Try them both and replay me for the answer. So we multiply 5 times 10, we get 50. Factor this out, 5 times 10, 2 times 5, 2 times 5 times 5. Cross it out, bring it out. 5 on 2. And here we get square root of 48. Square root of 48, we've got 6 and 8, and we got 2 and 3. 8 is 2 and 4. 4 is 2 and 2. And when we list those out, we've got 2 times 2 times 2 times 2 times 3. We got 2 pairs. Okay, now when we bring them out, we cross it out, bring one out, cross it out, bring one out. And we're only left with 1, 3 on the inside. But when I have it brought out and I'm bringing out more than one, you're going to multiply them together. So this is 2 times 2, which is 4, square root 3. Okay? And I like to go ahead and just list all the ones that we're bringing out. That way you don't get confused when we get larger numbers. So when you cross it out, bring one out, cross one out, bring one out, and then we can multiply later once we get them all crossed out and brought out. Okay? So the square root of 48 is 4 square root 3. Okay, now here we've got numbers and variables and exponents and all sorts of crazy stuff. So remember at the very beginning when I said I would explain it later, this is what I was talking about. So we've got variables with exponents here. Now if I bring out any exponent that is an odd number, remember I've got to have those absolute value signs. So I'll show you what I'm talking about. So we're first of all going to just factor this like normal. So 32, we've got 4 and 8. And then that's 2 times 2. 4 times 2. 2 times 2. And we list under the radical sign. So this is 1, 2, 3, 4, 5 2's. And then I want to list all of my variables so no variable has an exponent greater than 1. So times r times r times s times s times s times s times t times t times t times t times t. Okay, so from here, I'm going to find my pairs. One pair here, one pair here, one pair here, a pair, here's a pair, pair, pair. Okay, so you can do them in different colors if it helps you see where you've found your pairs. So here I'm going to cross one out, bring one out. 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 Cross it out, bring one out. Cross it out, bring one out. Okay, well what am I left with? I'm left with a 2 and I'm left with a t. So that remains on the inside, 2t. Okay, then I want to simplify this mess out here. So 2 times 2 is 4. R is just plain r. S times s is s squared. And t times t is t squared times the square root of 2t. Okay, now remember that rule. If you pull out anything that is odd, okay, any odd exponents, then you need to have absolute value signs. So this r is odd because, you know, r to the 1 is an odd number. So I've got absolute value signs around r. And I don't need it around s and I don't need it around t because both of those are even. 2 and 2 are even. Okay, I want you to try this one. Pause me and replay me when you're ready for the answer. Give it a shot. Okay, so this one comes to 8 and 7. 7's prime. 2 and 4. 2 is prime. 2 times 2. Okay, we've got quite a big list here. So we've got 2 times 2 times 2 times 7 times x times 1, 2, 3, 4, 5, 7, 8, 9, 10, 1, 2, 3, 4, 5. Okay, so once you get them all listed, going to be a big line, you want to find your pairs. 2. Here we go. Here's a pair, pair. And we cross one out, bring one out, cross one out, bring one out, bring it out. Cross one out, bring one out, cross one out, bring it out, cross one out, bring it out, cross one out, bring it out. And what do we have left? We've got 2 times 7, which is 14, x times z, which is just simply xz. Okay, so we're going to simplify this right here, the outside, and we've got 2 y, 1, 2, 3, 4, 5 y's, y to the 5th, z squared, square root of 14 xz. Okay, look at your answer. Is there anything that you pulled out that was an odd exponent? Yes. So you've got to have absolute value signs around this y to the 5th. Okay, another example of when we have fractions and we're dealing with radicals. Okay, so remember we have to, that quotient product property, or the quotient property, we can split this up into square root of 10 over the square root of 3. Okay, and then that very last little piece in our key concepts, we talked about rationalizing the denominator. And that's because I cannot have a square root in the denominator and it be simplified. So how do I get rid of that? Well, I'm going to multiply by the denominator on the top and bottom. So I'm going to multiply by the denominator of square root of 3 over the square root of 3. Okay, so you just take your denominator and multiply the top and bottom by the denominator. So then from here, we follow that product property, and we can multiply the radicands. 10 times 3 is 30. And square root of 3 and square root of 3 is square root of 9. Okay, and then from here, we know the square root of 9, it's a perfect square, as 3. And the square root of 30, we come over here, do a little scratch work. And we have 2 times 3 times 5. Okay, now if we don't have any pairs, there's no pairs involved, then it's actually all the way simplified. So we don't have to do anything. We can just keep this as square root of 30 over 3. And this is completely simplified. Now over here, if we've got variables involved, we are going to do the same thing. This one's already split up, so we don't have to do that first step like we had over here on the left. So we're going to multiply by a square root of 6 times a square root of 6 on the top and bottom. And this is going to eliminate our square root in the denominator. You'll always get a perfect square when you do this. Okay, so we're going to multiply 2n times 6, and we get square root of 12n over square root of 36, which is simply just 6. Okay, so we're going to simplify this square root of 12n. Here we get 2 and 6, 2 and 3. And we simplify, or we write it all out as 2 times 2 times 3 times n. We've got one pair. Cross it out, bring it out. So this is 2 square root 3n over 6. Okay, now from here, you can actually keep simplifying. And this only works when the numbers are outside of the radical sign. Okay, this is outside of the radical, and this is outside of the radical. Okay, so 2 over 6, we know reduces to 1/3. So I'm actually going to reduce this to 1/3, so square root of 3n over 3. And this is your final answer. Okay, quite a bit of steps, but make sure you're just showing all your work, and you got one step on each line, and you'll be just fine. Okay, here is a your turn. I'd like you to pause me and replay me when you're ready for the answer. All right, so first of all, we should have split this up into square root of 14 over square root of 5. We rationalize the denominator, and we multiply by square root of 5 on top and bottom. We get square root of 70 over square root of 25. And we know the square root of 25 as 5. So we come over here and we rationalize square root of 70. And we get 7 times 10, 2 times 5, 2 times 5 times 7. There are no pairs, so we just multiply it back together and we get square root of 70 over 5. Okay, now here are a few practice problems. Here's that I would like you to have for tomorrow or the next time we see each other. And don't forget to be writing your questions in the margin of your paper, and we'll make sure we get those answered first thing next time we see each other. Good luck.